We are on arc length. So get this stuff down. We're only doing 4 problems today. You need all of this down. It's gonna be going into your test grades, right? Arc length practice. So this is different than arc measure. In the last lesson, we did arc measure. We're bringing back this formula of arc length. So arc measured. If you're talking about the measure of an arc, it's a degree measurement, right? So it's going to be in degrees, like 75 degrees, and it's equal to its central angle. So like if you looked right here, since this is 170 degrees, this would be 107 degrees, right? That's how it works. But this is the degree measure. We're looking for arc length, and that's a part of the circumference, and that's a length, not a degree. So it'd be in inches or meters or something like that. So we're going to use this information to figure out how many inches, or in this case, meters long is the bolded arc. All right, so find the length of the bolded arc. We are using this formula. And you will need a calculator. Let's see. All right. Might have zoomed in too much, but it'll be fine. So let's pull out this formula. I'm going to say arc L. I don't want to write out all of arc length, so I'm just going to write arc L is equal to theta over 360 times 2 pi r. Now we're going to fill in stuff that we know. So I don't know the arc length, right? I'm trying to figure out the arc length. Theta. Theta refers to the angle we're using. We're trying to figure out this bolded line, and the angle inside this bold is 107. So I'm putting 107 stays over 360 times 2 pi r. 2, instead of pi, we use 3.14. And instead of r, we figure out what our radius is, and it says it right here, 6 meters. All right, when I'm plugging this in the calculator, I do want to make sure I put this in parentheses. Always use parentheses just to be safe. So parentheses, 107 divided by 360 times 2 times 3.14 times my radius, which was 6, and I get 11.19. Let's round this to 11.2. And what is the unit? Meters. Not degrees. It's going to be a unit of length. All right. You can pause the video if you would like and try this one, but I'm just going to get right into it. So now, they want us to find the length of the bolded arc. I am, again, going to bring out my formula. Arc length is equal to theta over 360 times 2 pi r. I'm going to plug in things that I know. I don't know the arc length, so I just rewrite it. Instead of theta, I'm using the angle of the bolded. This 142 does not belong to the bolded, right? It belongs to this thinner line. So if I want the angle of the bolded, I have to take 142 and subtract it from 360. So 360 minus 142 is 218. This is the angle that I'm using. This is the angle for the bolded part, right? This 142 belongs to the thin part. 218 is the bolded. So instead of theta over 360, it's 218 over 360. I'm going to put this in parentheses, times 2 times 3.14. Instead of r, we're using 4. All right, I'm going to put this in my calculator. 218 divided by 360, close my parentheses, times 2 times 3.14 times 4. 15.2. And in this one, we were using centimeters because that's what's on the radius. All right, 2 more problems and we're done. I don't remember how many problems I said we're gonna do. I know I think I said either 4 or 5, but it is just 4. All right, so now we're here. We're on number 3. It's important to follow these steps. All right, so they want us to find the length of CD, not the measure, the length. So we're gonna be using that formula we use in the top 2 problems. Let's follow these steps though. Fill in all angles. So if this is 68 right here, this is 68, right? Because they're vertical angles. Now, if I want to figure out what this is, I'm taking 68 and I'm subtracting it from 180. The reason why you subtract it from 180 is because these are a linear pair. And if they're on the same straight line, they add to 180. All right, if this is 112, its vertical angle is also 112. All right, step 1 is complete. Find the radius. So right here it says from E to B is 15. So from E to B, I'll do this in a different color. E to B, that's what this piece of information here says. From E to B is 15. And that's our radius, right? It goes from the center to the outside. That means my radius is 15. All right, the last piece of information we need to figure out is we have to use the equation to find the arc length. So let's figure out what CD is. This is CD right here. The angle inside that we are using is 112. All right, let's bring out that formula. Arc length is equal to theta over 360 times 2 pi r. All right, instead of theta over 360, we're going to use the angle that's paired with this arc, which is 112. So instead of theta over 360, it's 112 over 360. All right, times 2 times, instead of pi, it's 3.14. And then what was my radius here? Remember? 15. All right, you should get your calculator out at this point. Parentheses, 112 divided by 360 times 2 times 3.14 times 15, 29.3. So the arc length is 29.3 centimeters. All right, and then lastly, our most typical problem for this lesson. We're gonna be following the same steps, but we're trying to find UT. All right, step 1, fill in all the angles. This actually shouldn't be too bad. All right, so this is 127 right here. If this is 127, this is a linear pair, right? So whatever 180 minus 127 is, should tell us that other angle. So this is 53. If you want to pause the video right now and try this problem on your own, you can, but again, I'm going to keep going. All right, if this is 53, right in here is also 53. These are vertical angles. All right, this one was 90, 53. I have one more angle to go. 2 ways I can do this, right? If this is 90, this is also 90, or these 2 angles add up to 90. So I can do 90 minus 53, and I get 37. Or I can do right here, I have a straight line. So what's 180 minus 90 minus 53? You'll still get 37. All right. Now they want us to find the radius. So they say from V to S is 12. V to S is 12. Well, we don't want that whole thing, right? We just want half of that because we just want the radius. So if B to S is 12, then V to W, or our radius, would be 6. All right, now use the equation to find arc length. It's a good habit to write the formula out every single time. Arc length is 2 pi r times theta over 360. Let's fill in some stuff. All right, theta. What is our theta? What arc length are we trying to find? It says UT, so U to T. The angle inside UT is 37 times 2 times 3.14 times our radius 6. Calculator. .87, meaning 3.9 meters. All right, that's it.